This episode of Real Engineering is brought to you by Audible. Get your first audiobook for free at audible.com/realengineering.
An extensive program of research and development in the field of disc flight, which was started in 1952, is being conducted by Avro Aircraft Limited at Malton, Ontario. Early studies on behalf of the United States Air Force proved the feasibility of a circular planform vertical takeoff aircraft utilizing a system of peripheral jets for propulsion, stabilization, and control.
What you are witnessing is one of the most bizarre technologies of the mid-20th century. The year was 1960. The Cold War was looming over America, and within 5 years, American troops will be entering Vietnam, many of them by helicopter. The helicopter's role was clear: a vertical takeoff vehicle capable of rapidly deploying behind enemy lines with no need for runways. It could carry both men and weapons and serve a multitude of roles, but its speed and maneuverability left it vulnerable to attack, and it could not intercept enemy planes. The Avrocar was envisioned as a solution, a new type of airframe that could fulfill both the role of a helicopter and a supersonic jet fighter. And it all began life as Project 1794, with the goal of creating a vertical takeoff and landing aircraft capable of flying at 3 times the speed of sound with a service ceiling of 100,000 feet. This all sounds like it was born from the imagination of alien conspiracy theorists, but the design was perfectly logical in the mind of John Frost, a renowned and respected design engineer. John's concept for the Avrocar was seeded from his experimentation with combining 2 physical phenomena, the Coanda effect and ground effect. The Coanda effect is simply the tendency of a fluid to follow the curve of a convex shape. Modern planes, like the C-17, take advantage of the effect with flaps which can descend into the exhaust flow of the engines during landings. This would redirect some of the exhaust downwards to provide additional lift, allowing the C-17 to slow its approach speed and land on shorter runways. Most online publications on this vehicle overstate the importance of the Coanda effect, and in some cases completely confuse it for ground effect. While there are many test videos of John Frost experimenting with the effect with small prototypes, the effect does not get a single mention in the initial secret white paper where early designs were presented. There were multiple concepts drawn up for the Avrocar, but they all centered around one basic idea: direct high-pressure air 360 degrees outwards and use shutters and control surfaces to redirect it for control. The Coanda effect was not a feature of these kind of devices. The initial Blue Sky design called for a completely novel engine layout, which would not use conventional jet engines for power. Instead, there would be one large diameter engine surrounding the pilot, with the compressor stage mounted on the inner diameter, the turbine mounted on the outer diameter, with a combustion chamber in between. A major change from typical jet engines, which have these stages mounted sequentially over a common axle. This new engine would have been an ideal use of space, with fuel tanks mounted in a ring around the pilot, which presented a massive fire hazard but kept the center of gravity as close to the center of pressure as possible. However, designing an entirely novel engine for the prototype would have been far too costly, so a compromise design was created for the early prototype designs. Commercially available turbojets would be mounted radially around the disc in a repeating pattern. This created a radially symmetric design that would allow for repeating sections identical in construction. This was a huge advantage for the flying disc design, as it would reduce the number of parts needed, thanks to the radially symmetric design resulting in repeating parts. This would drastically reduce manufacturing costs. These turbojet engines would be mounted around a central turbine. The outlet pressure of these turbojets would drive this turbine in the middle section, and its remaining kinetic energy would be used to provide lift by exhausting it directly downwards. Meanwhile, the rotation of this turbine was powering 2 impeller levels mounted above and below the turbine, These centrifugal impellers would draw air from intakes above and below the disc and accelerate it radially outwards through ducts. Some of this air would be redirected into the inlet of the turbojet engines to maintain a constant ram pressure, which is the pressure we typically associate at the inlet of a jet engine as an aircraft forces itself through the air. For this design, I don't see much of the Coanda effect being used, as the air has no other option than to exhaust in the direction the shutters allow them to. This was the general concept behind the Avrocar, but the two prototypes that were actually built were much lower in spec, with 3 turbojet engines instead of 6. Here, they were mounted tangentially rather than perpendicularly to the inner turbine, which would drive the inner turbo rotor, which would work similarly to the F-35's direct lift rotor by directing some of this air directly downwards. However, it differs from the F-35 as some of that air was expelled outwards too. For these prototypes, the Coanda effect may have played a larger role, as some of the air was directed over the outer surface of the aircraft. However, this prototype was underpowered, with a huge amount of energy being lost through friction drag in the ducting system and through powering the turbo rotor. Using a geared drive system similar to the F-35 would result in far less friction and energy loss. This prototype relied completely on the lift boosting effects of ground effect to achieve liftoff. Ground effect is simply a boost in lift when an aircraft is close enough to the ground to create a high-pressure cushion of air between the vehicle and the ground. But this created some issues for the prototype. Here you can see John Frost, perhaps unintentionally, demonstrating the first with his early tests. He lifts the small prototype out of the ground effect zone, where it no longer has enough lift to keep itself aloft, and then lets go, allowing the scale model to drop back into the ground effect zone, where the high pressure air acts like a bouncy castle. The model begins to bob up and down until the motion has finally been dampened out. This bobbing motion can be an annoyance, but a far larger issue was an aerodynamic instability the designers of the Avrocar dubbed hubcapping that it could cause. This was named after the motion a hubcap or any circular shape would make as it rotated around its rim. You can see the pilots of the Avrocar struggling to control the vehicle in most of the archival footage of its testing. They likened it to trying to balance on a beach ball, a constant physically and demanding task. This was again caused by how ground effect interacted with the aircraft at various altitudes. Ground effect means that lift rises the closer to the ground you are, but this causes issues with aerodynamic instability when the Avrocar was tilted. Here, the right side of the vehicle comes closer to the ground and the left side moves further away. This causes the center of pressure to shift to the right as the lift shifts to the right. This, however, did not act as a restoring force to keep the Avrocar level, as the vehicle needed to keep its nose down in order to move forward, which shifted its center of weight forward. Instead, it resulted in the Avrocar swinging around its pitch and roll axis in that hubcapping motion. Over the next year, the team worked on fixing this issue. The turbofan itself was intended to provide stabilization. The turbofan would desire to remain in a horizontal position through gyroscopic action. So, the engineers developed a system where they could couple this action to the controls at the outer rim of the aircraft. They did this by mounting the turbofan to a gimbal, allowing the Avrocar to freely rotate around the turbofan. If the Avrocar deviated from this horizontal position, it would cause linkages connected to the gimbal system to move and shift the control surfaces to correct the tilt. As clever as this system was, before the age of fly-by-wire technology, it could not compensate for the inherent instability of the aircraft. The prototype was modified over the testing period with different control mechanisms, but none of them could solve this instability problem. The gyroscopic effects were having negative effects elsewhere too. The Avrocar took 5 seconds to rotate 90 degrees counterclockwise, which is too long to begin with, but it took over twice as long at 11 seconds to turn clockwise against the rotation of the turbo rotor. John Frost attempted to address some of the problems in 1961, designing this variation of the Avrocar, which included a wing and a tail to provide lateral and pitch stability, while moving the cockpit to the front of the vehicle. Ultimately, it was too late. The design was ditched as it was simply converging into a plane with VTOL capabilities, which were in research at that time, like the Harrier jump jet, which would fly its first flight in 1967 and enter service in 1969. Today, we can see aspects of its design being used in the F-35 with the turbo rotor, while the instability issues with hovering and ground effect are barely an issue for this aircraft, with advanced computer control reacting to wobbles before the pilot has even time to notice them. Who knows, if the design was revisited today, the flying saucer could truly exit the realm of science fiction. After all, most of science fiction is based on true science potential. We can learn a lot about science through exploration of hypotheticals in audiobooks like We Are Legion, We Are Bob. Easily one of the most enjoyable science fiction series I have ever listened to on Audible. We Are Legion, We Are Bob explores what artificial intelligence combined with von Neumann probes or self-replicating spacecraft would look like. This book tells the story of a young software engineer who dies and finds his personality has been uploaded to a space probe, destined to explore the universe and battle with space probes from competing nations. The book is amazingly funny as we witness a man trying to keep himself entertained with only ever stranger versions of himself to keep him company. Easily one of the most entertaining and informative audiobooks I listened to last year. You can listen to this title for free if you visit audible.com/realeNgineer.